So I just ordered Filastruder to potentially create my own 3D printing filaments. And I thought I'd make a video because the thing comes in pieces and you have to build it yourself. So what I have here is a serial number in the 4000s. So this is a 2.1E. If you're watching YouTube, there's a lot of different versions of this, and so depending on when you got this, you should double check what version you're looking at. I think a lot of the mechanical parts stayed the same, but the housing has changed a bit, and there's been a few upgrades over time. So this is 2.1E. So what comes in the box? Sticker with a serial number. So like I said, in the 4000s, some shipping details. It comes with an amount of ABS pellets. Let's see here. So there's two bags, if you look at the instructions. One is called the mechanical bag. I'm going to assume that's this. It's full of a lot of hardware. It comes with an electrical bag, which I'm going to assume is this, full of electrical stuff. It comes with insulation for the extruder. It comes with a sort of auger feed screw. This is going to rotate, and as it rotates, it pushes the pellets towards and out to be melted. Comes with this laser cut enclosure, which is actually quite cool. I mean, this is the kind of thing you can buy from your hardware store, but it would be pretty hard to cut this feeder for the pellet. As nice as this anyway. I don't have a laser cutter at home. So the screw will go into this eventually. It comes with an aluminum chassis. 12-volt power supply. This is part of the power. This is, I believe, the temperature controller, digital temperature controller. Chip protection board, I think they call it. I think this is the extruder part. And then the gear motor. Yeah, sorry, this is the brass plug nozzle. And then it also comes with this really nice sort of housing assembly, so that the newer versions are a little bit less, just, you know, stuff bolted to wood. And then you have the option of either printing, this is sort of the hopper assembly that will eventually feed the stuff into here. You have the option of printing this yourself, or I think they sell it for around 10 bucks, but they give you the 3D part file to print it yourself, so that's what I did. So let's take a look in these boxes. So here is the motor. Power supply, which I suppose with this plug. Digital temperature controller. That's nice. Cool. Okay, so mechanical assembly is the first step. I'm going to start by opening up the mechanical bag. There's a lot of screws in here. So, you know, obviously 3D printing is sort of meant for DIYers and, you know, people that are mechanically inclined. So, you know, you're not buying device here. You're buying a kit to build a device. And so it's always a good idea not to lose bits of hardware. So the first step is to attach this collar to the auger shaft. So basically it says to slide it all the way to the end. And there's a really wide tolerance for the distance here. So a lot of the pictures you'll see people using digital calipers, but there's like a 4mm tolerance. So my calipers, can't currently find them, but it says if you're within 79 to 82 millimeters, right? So I'm sitting at 80 millimeters right now, so basically you're fine. But basically you slide it all the way to the end, and you know, if you're outside of that range, you have to call customer support anyway. So double check. Easily within 4mm tolerance. If you have digital calipers, go ahead and use them. Okay, so we're going to open up the electrical bag now. Again, I like putting it in just some kind of container. So there's wires, but there's these black rubber grommets that we need. Okay, so the first thing we're going to do is make the chassis. So we've got the motor, and it rotates this shaft. And so the aluminum housing has kind of two sides. The big hole is going to go down. And then, it doesn't say which screws to use, but I'm guessing that it's obvious based on which ones fit. If any of them fit. There we go. So, several sizes of screws. The ones that fit here appear to be sort of what I would describe as medium-sized. Yeah, so you've got little ones, medium ones, and bolts. These seem to be the three main sizes, as well as these really long ones, but I'm sure these are for something else. So this medium size. So we're going to attach the chassis. Okay, with this assembled, the next step is to add the washers and the bearings. They come in a box and some bags with this logo on it. They look like this. The instructions say it's a good idea to oil the bearings, so you've got a metal washer, the bearings. I just have some kind of light bicycle lube here that I'm going to put on this for my bicycle chain. The next washer, and then the mechanical bag has this sort of plastic washer. That all goes together like this. The socket, so the socket goes on here, and then that all goes like this. Now, there's supposed to be another one of these spacers. So the first surprise think I'm supposed to have 2 of these plastic washers, but I can't, there's only 1. So I'm probably going to have to go to the hardware store or call their customer support. So it looks like one of them goes here, then the socket, then this all comes down. And it says that you want a couple millimeters of play here. So if you can see how that's going up and down, that looks good. So the other plastic washer is supposed to go right here. Okay, so this only came with 1 of these plastic washers. So I went to Ace Hardware and I found this nylon washer. The thickness is the same, which is the most important part. The diameter, it's about a ½ millimeter or a millimeter wire, this nylon screw. And then my plan is to basically drill it out between 2 pieces of wood. So I've already drilled a hole to get the diameter, so the problem is the inner diameter is different. So I'm going to drill it out with the drill between these 2 pieces of wood. There we go, replacement. It should fit. Yep. So this was 89 cents at Ace Hardware. The part number was 59568-C. It was a whole like nylon screw and washer section. So the nylon screw I bought, I'm going to put on the top because it'll be easier to access. Yep. So then the next step, there are these plastic nipples. They're in the electrical bag. They go here. There's 2 holes, one here and one on the bottom. So, you can squeeze them in, or I've got these forceps handy, which work pretty well. That. Okay, so the next step is going to be to attach some of this nice housing they gave me. And there is these cool little spacers you have to pop out and use. It's much nicer than some of the earlier models that you find videos on YouTube for, where people had to build their own kind of housing out of wood. Now this is purely cosmetic, but it's still kind of nice. Okay, so then the bolts you're going to use. The bolts you're going to use are these ones. There's only 4 of them, and you need 4 for this. Pretty easy to tell which nuts match. Okay, so we're going to take 2 of these laser cut spacers, put them here. Then you're going to take this body assembly with the hole facing towards where the rubber nipples are, put that on top, and then this flange housing thing goes on top of all of that. So when it tells you to assemble all this, it doesn't actually say, but the pictures later on show this opening, the laser cut opening here, facing towards the motor. My guess is that you could put this together a lot of different ways, depending on how you wanted to set it up, but I'm going to do it this way, with this facing the motor. Okay, and it does say to leave these a little loose during assembly, so it's nut, 2 of these laser cut spacers, the body, the flange, washer, nut, finger tight. Okay, so it says to check that somewhere between 2 and 10 millimeters of the auger is sticking out of the front of this, which is good. I've got 6 millimeters here. Again, it's a pretty wide tolerance. So the next step is this coupling to thread it onto the nipple. So that's what this is. It seems to be the same on both sides. So there you go. It's not going to screw all the way on. You can see that in the instruction pictures, but you'll figure that out for yourself. Okay, then, so the next step is to add this brass plug that has a hole drilled in it for the filament to come out. So mine came with 2 pieces of screen and this little thing to sort of hold the screen in with an arc spanner. So the screen fits in there. I don't have the right sized arc spanner, but so it's not at all clear to me whether this screen is necessary or not, but since it's in here, I'm going to install one of them on the assumption that it'll be easier to remove it than to add it back in later. I don't know if that's a good idea or not. If anyone knows, feel free to leave me a comment. Some of this stuff, I don't know if it's sort of just like prepackaged, and you know, this brass plug is obviously not meant for this. It's meant for some kind of natural gas application or something like that. Alright, so yeah, I put the screen, hopefully you can see this, I put the screen and this little kind of holder in with the screen. Again, not at all clear to me if I was supposed to do that or not. And then I'm just going to thread this onto here. Something that the instructions also don't really say is you get all these really slick laser cut kind of body housing, but the this is just covered in paper. It doesn't come off really easily, but this is going to look a lot nicer if you peel the paper off. So it doesn't come off super easily. Maybe everyone in the world knew this but me. You can feel free to make fun of me down in the comments. But if you just kind of get it started, it does peel off. And then it's going to look really slick with this sort of shiny black housing, compared to some of the early models I've seen on YouTube where you know, people had to do a kind of DIY kind of wood thing. Yeah, so you get this really nice slick plastic. I'm not going to make you watch me pull that apart. Yeah, so then that's the mechanical assembly other than the 3D printed hopper. And so it says it sort of somewhat confusingly says to have it so that the threaded part for the bottle is facing away from the motor. At first I thought that meant to have it sort of upside down, but I think all that means is that you want it on this side. So it's got this little square part and the round part. You want the round part on this side and the square part facing the motor. And then when you put this on here, it pretty obviously brackets the hole here is the exact same size as the hole here. So that's really nice. So you can line it up. And again, the tolerances are pretty big. That's what I've done. And so now, supposedly, the mechanical assembly is done, and we begin the electrical assembly. So the next step is to install this heating band coupling, which is pretty cool. It comes with this sleeve around it. I had to bend mine a fair bit to get it to go over, but you want it to go around this coupling here. There we go. And then I'm going to guess that doesn't need to be that tight. Yeah, and so I'll send these wires along the bottom. I've installed the heating coupling with the wires on the bottom. It doesn't actually say, but I'm assuming that that gets threaded in through this hole here and then interacts with the electrical circuits in some way. Suppose we will find out shortly if that's wrong. Okay, so the next step is to attach this protection board, which is in this static bag. A bunch of the hardware in the bag. There's a couple of these brass standoffs and some M3 nuts. And somehow this piece of the housing is involved. The instructions are pretty unclear at this part. It almost looks like they show it facing up, but I don't know how that would make any sense. All it says is to install it. Install the stall protection board using provided hardware. M3 screws in large mechanical bag, which I guess are these. M3 screws in large mechanical bag. They seem to have this sort of hex top, like an Allen key. M3 standoffs and nuts with the stall protection board. So I guess I'll install the standoffs onto the board, because why not? Okay, so the battery cut out on me when I was putting the standoffs on, but they're all there. So the 4 standoffs with the screws. And then in the picture, this housing here is sort of bracketing the display here. And so there are 2 M3 screws here with a kind of like a knurled head and a hex head. So those are going to probably connect all of this together. I don't see any washers or anything. Okay, that's that. So this also came with this heat sink, but I can't actually figure out where it's supposed to go, and the instructions don't say. So we're going to put that here for now. So when we look at this, the instructions really make it look like it's attached this way. It's not at all clear to me how that makes sense with the rest of the wiring and the housing, but it looks like there's decimals here. So you've got numbers and the possibility for decimals. So I'm just going to assume that that's how this goes for the time being. Hopefully, it'll be pretty easy to swap it back around. These seem like unnecessarily long screws. Okay, so that's that. Okay, so the instructions talk about this bracket that goes on the PID controller. And it says if you want to use it, you have to trim off these little hooks. So if you want to use it, I don't know what that means. So I'm going to use my Dremel and I guess just trim those off in case I want to use it or possibly need to use it. Okay, so these funny little hooks, cut them off. There were some screws going through, which it's sort of easier to take those out and cut. Dremel's probably overkill for this, but it makes light work of it. So I guess if I want to use this, I can, although it doesn't even say why or when you might want to use it, but there it is, it's cut. So the next step is to put the PID controller into here. I guess all this would do is hold it in. I suppose that's good. That's a smart idea. Yeah, so that's good. I guess that's why you'd want to use it. So this goes through the big hole on the the only hole that it fits, and then this white bracket. I cut these funny hookies that I have no idea what they're for off, like it said, and then it just clips into these. It clips into the side, and I guess that just holds it in there. So that's that done. The next thing it says is that it comes with 11 inches of wire with a DC plug on the end. So that is for this whole unit to power it. So eventually this will be wired up, and then this will all go together to go to the socket. Put that aside for the time being. Put this aside for the time being. And it says it also comes with 18 inches of 18A WG wire. So there's red and black, and you can see, I can't show you, it's too small, but it says what it is on the side. That's these two. It's way more than 18 inches, so that's good. And this is going to get cut up to do the internal wiring. Okay, so basically after you get to this point with the mechanical build, it tells you to move on with the wiring, and those instructions are actually really brief. So I'm just going to start kind of winging this. So I think the first thing I'm going to do is attach the two fans to these two pieces. I noticed, so yeah, first of all, I cut this little, these are computer fans, so I cut these off because we're not going to need them. And then I noticed that one of them was a much longer wire than the other. I'm assuming this is on purpose, and so since one of the fans is going to go way out in front here, I'm going to use that fan in the front and the shorter wire for the motor fan. And from the look of the picture, so this is the piece that's going to cool the filament as it comes out, and zip ties are going to go through here. So we're going to attach this fan, which is already potentially damaged. That's fun. I just noticed that the black wire, the solder has come off. I don't know if you could see that. So I guess step one is going to have to be to repair repair this wire that's come off. It's a little bit annoying. Yeah, and the other one's okay. So I guess we'll start attaching that while the soldering iron's heating up. Yeah, I'm going to put it on. Yeah, okay, so I'm going to put it on the bottom. So I peeled the paper off. I feel like the inside doesn't matter. And I'm going to put it with the wire facing down. I doubt any of this matters, but it'll look a little cleaner this way. Yeah, and so it goes on this way, I think. So this is the front. So the switches have two pegs on one side and sort of a hole on the other side, and they're labeled 1, 2, and 3. And so if you can see right now how this is switched, my guess is that that's what's going to connect the circuit and turn this on. So you can think a little bit about how you want this to work, right? So I am going to put them in this way so that on is this way. All right, so then in the instructions, main is switch 1 and motor is switch 2. So I've just written that on the back to help myself out a bit. It also talked about how I had to cut these arms off of this white bracket that sort of keeps this from sliding through. It seems it's square, right? So you could put it on facing up like I did, or facing side to side. If it was facing to the side, these would definitely be in the way of the switches. But if you have it facing up, I don't really know why you had to remove those. If anyone knows, you can leave a comment. If anyone leaves them on and it works fine, that could be a good comment too. But I cut mine off as you saw. It's plastic, so it's not. What I've done here is so switch 1, switch 2. I've made this little connector so it goes between the two switches, and then this can go off to the. This can go off to the controller. So we are going to go from the outer pin of switch 1 to the outer pin of switch 2. So haven't connected anything to the middle yet. And then this is going to run up to pin 9 on the controller. It's a bit hard to see with the lighting in my basement. But they're numbered. They're numbered starting. You see how there's only 4 on this side and there's 5 on this side. So 1 is at the top here, then 2 is empty. 3, 4, 5, 6, 7, 8, 9. So 9 is down here, which means we need to run this up and over. Okay, so that's that. Again, the 2 outer pins are connected. And then from switch 2, I've got this one going up to 9, which is, if you can see that there's 4 on this side, 1, 2 is empty. 3, 4, 5, 6, 7, 8, 9 to pin 9. Okay, so I've got the filament fan thread into the housing through this grommet that we did down below. What I've got to do next is connect a red wire to switch 2. So we're going to continue with the wiring. We've got the switches connected to one another and to the controller. The next step is this wire that's going to go from the center pin of switch 2 to 9 on the control board. So remember, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 has quite a few things hooked up to it already. So there's that. This also, this little extra part we attached. Got this jumper wire between pin 8 and pin 9. Motor fan we can connect up to the stall protection board. So basically the red and the black go on the positive and negative of in. It's pretty clearly marked on the board, but in is on this side. It's the side with it's the side without the USB. So the red wire goes to positive, which is on the top, and the black goes to negative, which is on the bottom. Good. The black wire of the extruder pin fan is going to go to pin 10, which is the last one on the side that has 5 connectors, where the switch is also gone. good. Thing to keep in mind when you're cutting up the wire they gave you is that, so I'm setting this up kind of laying about, but when this goes inside, like this, the wires have to be able to reach up and around to the protection board, so they actually have to be pretty long. And they only give you 18 inches of wire, so you definitely want to plan out how you're cutting it up. We're going to attach this little jumper here from the outer part of switch 2 to the red fan. And I'm just going to solder those together and then use some shrink wrap. So I think we could probably just connect this to pin 10. Wire goes from the center pin. Yeah. So I think you could either connect this to the center pin or to this little wire jigger that I made, but I've already got this, so we're just going to use it. I'm running out of red wire. Alright, so that's that. The motor wires are going to go to the out on the stall protection board. So out plus and out minus. Now you may have to check these to know which way the motor is going to turn. Yeah, so just with this 9 volt, it doesn't give a lot of power, but it does rotate. So I think you're going to want to put the red into the minus to get it to go the way you want on the out terminal. Or sorry, into the plus. Red is going to go into the plus, which is at the top on the side with the USB, and black into minus. And we can double check this later because we want to make sure that it's rotating everything down the shaft correctly. So one of these heater wires, it doesn't really say which one, so it probably doesn't matter. Connects also to pin 10, which is the last one on the side with 5, where you've already got a couple of wires. The other heater wire is going to connect to pin 7. So again, from the side that only has 4. 1, 2, 3, 4, 5, 6, 7. 7 is just past, just above. If you've got it oriented like this, it's just above where that jumper went. Again, a bit hard to get the fabric-y covering off, but that should be okay. The wires to the motor terminal, and then the thermocouple, this little guy, is going to connect to pins 3 and 4 of the controller. And it says to be mindful of the polarity, so if you look on the side, so again, the blank one is 2, and then 3 and 4. It says that 3 is minus, and 4 is positive. And then if you look on the thermocouple, it says the same thing. So again, you want to make sure the positive is going to 3. I'm sorry, you want to make sure that the negative is going to 3 and the positive is going to 4. So I can't really show you that, but it's written on the side of the controller and on the thermocouple, so it's pretty easy to do that. just make sure that you do pay attention to that. Good. Okay, so I've done this slightly out of order. The last two wires is we need red wire coming from pin 9, which is a pretty busy pin right now. A red wire coming from pin 9 and a black wire coming from pin 10, and these are going to go up to the stall protection board. So red goes to positive, where we've already got the motor fan attached. And the black one, you can see that I cut these wires a bit too short, is going to go again up to the in minus. Okay, so the last step is to connect the DC wire. It talks about doing this at different steps, but everything else has colored wires. But so here, I don't know which is positive and which is negative. So I've actually plugged it in. This is a little bit dangerous right now. I've got my trusty multimeter. We're going to try to figure out which is negative and which is positive. Yeah, so in this case, the one on my left is power, and the one on the right is ground. So I've got that unplugged now. Unplug it from the container, and then I'm just going to put a little bit of this red heat shrink, just in case I lose it. Now, in my case, yeah, so they basically look the same. In my case, there was some writing on what turned out to be the red wire. If you don't have a multimeter, you could potentially go from that. But you're definitely going to want to make sure you get the polarity on that correct. All right. So the red, the positive, is going to go to switch 1's second pin. Got the temperature reader hooked up over here, but I hadn't hooked it up to read the temperature over here. The instructions say something about a hole in the extruder end, and that hole is here. And I tried for a while to solder it, and it just wasn't working. So what I did instead was I wrapped it around and then just bolted this tight. So it's underneath of this clamp, and it should be sensing the temperature of the plastic. And then I'm going to put it on the inside of the insulation just for cleanliness. And it says to put this on much earlier, but I think it makes sense to wait until the end. And I'm only wearing gloves just because it is fiberglass. And it's not exactly easy. Now it says that you can form it around, but you really can't. At least not that easily. Alright, so hopefully that's good enough. And then I'm going to sort of zip tie this fan onto the end of the extruder with the zip ties that they provided. Yeah, I can't even close these. So the zip ties that comes with are way too small for this. I don't understand what they're thinking. So we are going to connect them together to make one longer zip tie. Which is a fun trick. And then we'll come back and deal with this later. Alright, so all the wiring is done. A little bit of red wire left over. So I'm just going to walk you through this all. Starting from the front, we've got the fan, and the wire goes underneath. There is the temperature coil that comes underneath the insulation and into the body, and then also the two heating wires. So we've basically got 4 wires running through here. The set for the fan, the 2 for the heater, and the 1 for the thermocouple. So those are running into the body. On the top here, sort of working our way across on this side of the board, this side of the USB, we've got the motor running into that. So the red is at the top in the plus, and the black is on the bottom. We've got the cooling fan for the motor coming in on the other side, again with the red at the top and the black on the bottom. We've got this red wire coming down that goes to the center pin of switch 2. And we've got this black one coming down that goes to pin 10 on the controller. So if we take a look at the controller now, it has all of these different pins. So on this side, it starts with 1, and then there's nothing, which is 2, 3, and 4. 3 and 4 is where the thermocouple goes. Definitely make sure you've got the polarity correct on that. So it has a little plus and a minus written on it, and there's a plus and a minus written below pins 3 and 4. So just match that up and you're good to go. Nothing in pin 5 or pin 6 is empty. Pin 7 has the heater. 8 just has this jumper that goes across to 9. And then also this black wire that comes down to the outer pin of switch 2, which is also connected to the outer pin of switch 1 with a little jumper that's a bit hard to show you. I've got this little jumper kind of thing connecting the two, and then that comes back up, and remember we're on pin 9. And then pin 10, the last one, has one of the DC in the ground. And again, this black guy going back up to the stall protection board that we already talked about. Coming down to the switches, right? So we've already talked about the red that has the fan at the front, as well as this wire that goes up to the stall protection board. Then it has the 2 black ones that are connected up here and to each other, and then the DC power line is coming in to switch 1. In case you're wondering how this works, so you can see the switches are up on this side and down on this side, and the pins are on the down side. So that's the off position. The on position is the other side, so sort of switching away from the 2 pins if you're trying to set it up like that. So you can see we've got something going on here, nothing from the motors. There are the fans, and the motor turn on. So we should be able to assemble this thing now. Okay, so for assembling this thing, depending on how much you care about what this looks like, you're going to probably want to remove the paper from at least both sides of these ones. You can get away with only one side of a few of the pieces. I would recommend taking these long screws and putting them in the side with the that has the wiring, sort of starting with that side. Where did I put the other 2? There they are. And this one is a bit tricky because there's actually a screw from the sort of motor assembly right in the way. So it can be a bit tricky to get through, for at least on mine. There we go. Alright, so the 4 screws and then lay it on its side. And the trick is getting everything to line up. The screws and these little tabs. Sort of work at cross purposes. So what I'm doing is tightening the bolts a little bit just to hold the thing together as I work my way around. There we go. Now it's just a matter of fighting your way through all these little tabs. Alright, and there we go. Alright, and then this hopper is designed to hold a soda bottle. So the last thing to do, if we look at the back here, with the stall protector, there's a whole page of instructions about how to set this thing. And so it talks about two adjustments labeled CV on the left and CC on the right. Mine is actually labeled CV and CI, but I'm pretty sure this is what they mean. Okay, so I'm going to edit this video and not show you. It says to turn these two knobs counterclockwise until you hear it click. And it says there's going to be potentially this is a few dozen rotations. I would say it's easily a few hundred rotations. I think I was rotating these for close to 5 minutes on each side. So if you're turning this and wondering if you're crazy, you're not. I doubt I'll be able to get the click on the camera, although I suppose I could try. I'll put my microphone really close. Did you hear that? That was it. Really light, little metallic click. I'm going to do it one more time. There, that was it. And so once you find it, sorry. Okay, so now I'm not shouting into the microphone. So once you find it, you can pretty much guarantee that you're there because it'll keep clicking when you do the rotation. So I've got both of these to 0. It takes an incredibly long time for me. I don't know why it's not set that way to start. So if we turn on the power, alright, so what we want to do is we want to turn this one on the left 15 clockwise. Cool, so the red light is indicating that it's current limited. blue is indicating that it's drawing between 10% and 99%. So I think we want to now basically get it so that only the blue light is on. So the next thing it says is that the one on the right should be about 7 turns clockwise from 0. So 7. So we want this reading between 11.5 and 12.5, so that's good. You can hear the motor going. And it says .5 and 1.7 amps. Okay, nowhere near. So it actually says that the green is normal if it's not actually pushing on anything. So I think we probably got this set up correctly. Okay, so the whole thing's put together. The last thing, the very last thing, I know I've said that several times in this video, but for real this time, the very last thing is to set up the PID controller. So when you turn it on, you'll see it cycle through a bunch of things. The lower number here is the temperature you've set it to. You can see I've already changed it to 180 degrees Celsius for the ABS that it comes with. I think the default was maybe 500, but I don't remember. And then the upper one in red is the temperature that it's actually currently at. So you can see I've actually had this running. So to set this up, you know, I'm normally the kind of person that can just start pressing buttons and figure something out, but this thing isn't incredibly complicated. It has thousands of possible settings. This is a temperature controller that you could use for a freezer if you wanted to. A lot of people, when I was trying to figure out how this worked, it seems to be really popular for home brewers that are trying to maintain stable temperatures for their brewing. But these instructions are in the Filastruder guide. So there's 4 buttons down here. Up and down is how you can change the temperature you want to set it to. What you want to do to really set this the PID controller up to start is you just hold down set, and you'll see it goes into this high AL. And if you just keep pressing it, 1, 2, 3, 4, 5, you get to this control setting. And the default is 3. And you want to put it into 2. And then you can either just let it hang out for 30 seconds or so, and I think it gets back to the thing, or you can cycle through all the other options. So I'm just going to do this so you can see how many possible settings there are on here. I have no idea what any of these things do. And the instructions that this came with don't tell you. When you get to EP, the instructions say, you know, you're kind of at the end. EP8 is the last one, so now we're back out. Okay, so I've already set mine up, so it's already doing okay, but basically this 180 AT thing, it's going to flash back and forth. When I first did this, it took about half an hour. So you just want to let it chill out. It's basically the AT, I think, stands for automatic, so it's basically automatically figuring out. I think the idea here is that, you know, if you set this up to a freezer or to some kind of incubation chamber for home brewing or to this crazy thing that's melting plastic, you know, every one of those environments is a little bit different. And so this controller has some automatic ability to sense what it needs to do to control whatever you've connected it to. That's my best guess of what's going on here. So just let it go, however long it takes. Like I said, for me it took about half an hour. And then once it figures out how to operate within the environment that you've put it, then you basically should be good to go. So I'm going to let this go for about as long as it needs to, and we'll come back and take a look at it. Okay, so it's been about half an hour since I put it into the automatic mode. And you can see that it's no longer blinking AT and the number down here. So it's set to 180, which is what they suggest for the ABS that it comes with. And then you can see that its current temperature seems to be fluctuating between 170 and 190. I don't know how good that is. So you can see it gets down to about 170, sort of blinking on and off. But once it gets below 170 is when it really starts trying to go back up again. Yeah, you can hear and see the heat switching on and off. Yeah, so there you go. You can see it got up to 190. It seems to drop down a little bit. I really can't find very much about the settings on this, and like I said before, it's enormously complicated. There are thousands and thousands and thousands of settings in here. And the instructions are really more of just a technical chart. So I'm going to let this heat up for a little while longer, sort of stay hot so that everything is appropriately warm. And then let's try to run some filament through here. So I'll come back in a few minutes. All right, I am going to put this ABS, why is this bag taped shut? It's weird. All right, so got into the bag. Let's try into the hopper. We'll switch on the motor. So if we turn this around, if you remember when we set up these two sensors, or these two screws, that it was only drawing about 0.3 amps. After it's been spinning for a couple of minutes now, you can see it's drawing more amps. It says it should be between 1.4 and 1.6, and that indicates that it's driving a load. And you basically want this green light to go off and the blue light to come on, which you can see we're really close to getting to. So the green light indicates it's only drawing a little bit of its load, and the blue indicates that it's basically in a normal range. So you can see we're getting there. We turn it around. There's still nothing coming out. Our first bit of filament starting to come out, the very end tip there. It's coming out really slow. All right, well there you go. This turned into a really long video, but I'm hoping that it helps some of you. I assume that most people are aware that you're not buying a product that looks like this in a box. You're buying a kit like you saw at the beginning of this video. This took me about a week to build in my evenings and weekends. It's a fairly complicated build, and I made a number of mistakes along the way, as you'll see in the video, or as you saw in the video. So my hope is that this video is useful to some of you. Keep in mind this is the version 2E, so I'm assuming there'll be a better version coming along in the future. So, you know, if it's 5 years from the date that I posted this video, maybe this is no longer useful. But as you can see, it is extruding, and it's working fine. I'm really happy with this. So it's going to run this through and just clean it, and we'll see how it goes. So my next video will probably be the fill a winder. But yeah, this was a pretty fun build, and maybe I'll do another video with some prints from the filament that I create with this after it's up and running. I'm really excited to potentially do some prints with recycled plastic that I generate around the house. So yeah, if you like this video, please hit like, consider subscribing. I don't make that many videos that often, but I do like building things, and I've sort of resolved this year to start making videos and hope that they're helpful to someone. So feel free to subscribe, let me know what you think. Leave a like and a comment if there's something you know about this that I don't know, and I will see you next time. Thanks! It's always a bit nerve-wracking when you have this many parts left over. Oh well, seems to be working.